In this video, we're going to be discussing angles created when transversal lines intersect multiple lines. In this case, whether it's a set of parallel lines or not parallel lines. In either case, they both have the same type of angle names. The only difference is whether the angles are congruent or supplementary. That part is not relevant in this situation. We're only going to focus on naming the angles. In this case, we have 6 different terms. We have same side interior, corresponding, alternate interior, alternate exterior, vertical, and linear pair. Now, same side interior could use a different name. That one could be consecutive interior, but in this case, we're going to use the name same side interior. Now, there's 2 types of options you have. You have the case where both angles that are being referenced are on the same side of the transversal or not on the same side of the transversal. However, the one that's very special is the linear pair, because that one can be same side or not same side. Now, we'll be using a couple examples here and using this little diagram to help us identify and make easier to name the angles. So on our first example here, as noted, the lines do not have to be parallel. We can make them parallel if we want, but that is not important. What is important is just naming the angles. If I have one here and one here, we'll just be using X and Y every single time. The easiest trick is to make your lines go vertical, and it's easier to see that the X is on the left side and the Y is on the right side. Thus, they are not on the same side, and we can ignore these. We have 4 options now: alternate interior, exterior, vertical, or linear pair. Now, these are not linear pair because they are not next to each other, and they're not vertical. Vertical means that they would be right across each other, such as 2 slices of pizza. Now, in this case, the angles are not inside the 2 lines that were crossed. Therefore, this one's going to be alternate exterior. Moving on to the next example. We have an X and a Y again, but this time, if I move my paper over to make this line vertical, I can see that X and Y are both on the same side of the transversal, on the right side. Since they're on the same side, my options are now same side interior, corresponding, and linear pair. Now, same side interior means that both angles here have to be in between the 2 lines here. Since they're not, it is not this option. Linear pair means that both angles must be touching each other, which they are not, so therefore in this case, this is a corresponding angle. For our third choice here, note that the left and right is where X and Y are located right now. One's on the left, one is on the right. They are not on the same side. Therefore, we have 4 options for our vocabulary term here. Now, in this case here, linear pair, they're close to each other, but they're not actually touching, so it cannot be a linear pair. Vertical, that is not going to happen on this one because they must be on the opposite side of each other, which are not in this case. Since we only have alternate interior and exterior now, well, these angles are interior, not exterior, because they're both inside the 2 lines. So this is going to be alternate interior. Very similar to the exterior angles, but in between the 2 lines. Now, one of my favorite ones here is this example. X and Y are both on the left side, so they are on the same side of the transversal. I have 3 options. Now, it is not same side interior because interior signifies that they're both in between the 2 lines here, which are not. Corresponding signifies that they're both facing in the same direction, as in they're both on the, in this case, this is on the bottom left of this intersection, and it would also be on the bottom left of this intersection, which X is not. Therefore, this is a linear pair because they form a straight line here, and they're a pair of angles. However, if I use this one more example here, a last example, place X here and Y here, just change the location of the X. Now these two angles are not on the same side. However, in this case, they were still a linear pair because they are right beside each other, paired up to make a straight line. So this is another example of linear pair. Although they're not on the same side, they can be on different sides and still be linear pair. This is that special case here on this diagram here. Hope the video was helpful, and if it wasn't, just leave a comment on what I can do to improve.